welcome to Aerotech's Automation1 version 2.5 motion control platform release update. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors, Galvo laser scan heads, and interfacing with other devices. In this video, you will discover new features available in the 2.5 Automation1 release. This includes beta feature sockets interface, a new feature is called the message log, motor and hull signal status module for setting up motors and hull signals, absolute encoder alignment module for helping you to set up absolute encoders on devices, machine setup improvements, both for Galvo laser scan heads and for absolute encoder support, new features to the MachineApps HMI development tool, such as a camera module, the message log viewer, and access control, and other improvements such as API speed for AeroScript commands. The access control user experience has been improved. There's been many improvements to software modules. The command queue usability and performance have both been improved. Many general improvements to our AeroScript programming language. The .NET, C, Python, and LabVIEW APIs have been improved upon, including a complete C help file. Gantry configuration improvements have been added to the software, and many improvements to tuning tools in 2.5. My name is Patrick Wheeler, and I'm a product manager for Aerotech. Let's get started with the beta features, which just include the sockets interface in 2.5. So what is a sockets interface? It's a way to interact with other nodes on a computer network. Automation1 supports sockets that use the Transmission Control Protocol, TCP. On a TCP IP network, every device must have an IP address. However, an IP address is not sufficient for running network applications, as a device can run multiple applications and/or services. So the network port is used and it identifies the application or service. This is important to note in our sockets interface. If you look to the right-hand side, you'll see the two PCs, one designated TCP server and one designated TCP client. We're going to go over what they do, but a quick summary is that the TCP server waits for one or more TCP client to connect, and the client connects to a TCP server that is waiting for the TCP clients to connect. So a little bit more detail about the server. What's really the purpose here? The server is created in order to wait for a TCP client to connect to it. Otherwise, it listens on a specified port. And if you look at the little image down below, you'll see that the controller port number is highlighted as being bold, and you can see a little ear there listening for a connection to be made. So when the Automation1 ISMC is configured as a TCP server, the IP address is a controller's IP address. And the AeroScript file is set up on a dedicated task, and the program function socket TP server accept is used. It is a blocking function that waits for a connection to be established. Because you're using a blocking function on a task, you shouldn't use this task for other functions such as motion control. Once a connection is made with a TCP client, the server application can read and write to the sockets interface. On another device or task, a TCP client is created and it seeks the specific server and makes a connection. So the client goes out and looks for, based on the IP address, the controller port number that was set up to listen. So the client needs to know what port to go out and look for. When the Automation1 ISMC is configured as a TCP client, the programmer must specify the IP address and port of the server of which it is trying to connect. If no TCP server is actively listening for this client to make the connection, then it's possible that the TCP client will just time out, and a timeout value can be specified on the TCP client. Once this TCP client establishes a connection with a TCP server, the client application can read and write to the sockets interface. So if you read that last bullet point, it's the same last bullet point that was on the previous slide. Both the client and the server are looking to establish that connection, and once they do, they can both read and write to the sockets interface. To close this connection, closing a socket, you can close it programmatically by using an AeroScript function, but please note that the controller automatically closes all sockets that you created on a task when the task stops or a task error occurs. So you would need to reestablish these connections when restarting that task. With sockets, you can pass binary data and string data. The binary data types you can read and write include floats, signed integers, and unsigned integers. And many different types of signed and unsigned integers and floats and single items and arrays are both supported in Automation1. For string data, you can read UTF-8 strings with delimiters, UTF-8 strings with specified length. And you can also write any UTF-8 strings. And there's some notes here on the right-hand side of the screen about what a UTF-8 string is. It is part of the Unicode encoding system. That Unicode system is an international character encoding standard that provides a unique number for every character across languages and scripts, making almost all characters accessible across platforms, programs, and devices. So this is a very universal format to communicate and commonly used in many programming languages. Next, let's go over our new features. Those include the message log, the motor and hull signal status module, and the absolute encoder alignment module. First, the message log. And there's a lot going on here, but let me walk you through this screen. If you look down at the bottom of the picture on the right-hand side, you'll see a part in red where the message log is shown. And then in the actual program, you'll see the message log function being used to write a string to the message log. And what you can't see in this actual image is the program, which is called cause_task_error.ascript, which is generating a task error that triggers that message log write function every time a task error is generated on this task. Okay, so every time that happens, a new line is written to the message log. And you can see that we index these messages programmatically with the rglobal++ function that adds a new number to that global reel and writes that as a script to the message log write function. So down below, you'll see that there's a number of task errors on this shift equals 3, 4, 5, 6, 7, indexing as we get more task errors on this actual program. This is shown to indicate how a message log can be used to track things that happen on your machine, in this case, task errors. Message logs are powerful because they allow a user to view messages logged with this function. And this is very useful for things such as debugging and troubleshooting, user messages and logging, and tracing the progress of a program. You can put message log functions anywhere intermingled with your motion commands. And so when you get so far along a program, you can write a timer out to the message log. The important thing is this is an easy logging interface, and messages are written to a log file. It's actually automatically saved in the controller file system. You can use a file system API in .NET, C, or other APIs to grab those files off of the controller. Next is our motor and hull signal status module. And for those who like to set up motors, this is going to be a very useful tool. It's a graphical tool that helps the user to visualize, verify, and troubleshoot problems with hull states and other physical signals for a specified axis, really for the motor on that axis, but some other things that might be axis related as well. For example, not only do you see this nice animation here showing how the hull states are changing, and if you look in the middle of that circular graphic that's rotating around in sequence, what's really going on here is as you turn a motor or move a linear motor, the hull feedback states change. And since there's 3 hull sensors on a typical motor, you see those 3 digits in the middle that are changing with the motion of the motor. And in this case, I'm actually just commanding a free run or a constant velocity move to a motor so I can show you how these states change. There's an expected order that they change in, and these green semicircle type graphics are changing in that specified order. If you would see it jump around from, say, B to CA to CB to A in some odd order, you would probably have to go and change your hull wiring on that motor to make it correct. There's some other signals that are important to setting up an axis that are shown here, such as reverse motion direction parameter, the brake output state, and quite frankly, a whole bunch of other things associated with limits, home, marker inputs, e-stops, and STO. So take a look at this when you open up Automation1 version 2.5. Next, there's an absolute encoder alignment module. And this helps users to set the commutation offset parameter for axes that have absolute encoders. You can specify a test current in amps, and then this tool uses that test current, sends it to the motor, and automatically determines the parameter value for the commutation offset. So it's kind of a single button thing that takes something that was once complicated and makes it very easy. All right, let's jump into the machine setup improvements. As you guys know, machine setup is our tool for easily setting up your axes of motion. First, some improvements to the Galvo laser scan heads and machine setups. Now, Galvo laser scan heads from Aerotech come completely configured and optimized. So when you go into machine setup, there's not really a reason to do that unless you're changing something such as an optic. You wouldn't, for example, ever need to change tuning parameters of a laser scan head product from Aerotech. So assuming you're going in there to change this optic, right now we are going to default show you a lot less things that are going to opt into being changed. So I no longer will machine setup try to change tuning parameters for a Galvo laser scan head. It will just default to the parameters that are associated with an optic change. So this should make it a lot quicker and easier for people who are changing their optic on their Galvo laser scan heads. An absolute encoder support in our device catalog and our machine setup tool for mechanical devices. You can now set up devices with Biss Absolute encoders with incremental sine wave signals. This is great for people who want to use absolute encoder stages, but also at the same time get the benefit that the incremental coders give to an Aerotech control system, specifically like position synchronized output PSO. We also support N.2.2 absolute encoders with and without sine wave signals and SSI absolute encoders, as you can see on the graphic here on the right, which is a nice call out of our very easy to use and more powerful than ever device catalog tool. Device catalog is great because it lets you set up mechanical devices, Galvo optics, for later use in our very nice and easy to use machine setup tool. So all of Aerotech's standard mechanical devices and drives come with machine setup. You don't need to do this, but if you get third-party things or you're doing custom things with Aerotech stages, you can use this tool to kind of get yourself tools that are available to be used in machine setup. Also in machine setup, a nice little feature we did that we added the units of milliradians for rotary axes in machine setup. So another little short call out to another user experience tool that we added in the machine setup tool. Moving on to our MachineApps HMI tool. MachineApps allows you to build wonderful and beautiful Windows-based HMIs. They are great front ends for your machines. They allow you to do things such as focus 100% on your company's branding and remove Aerotech's branding from the software completely. And there's a lot of power being built into MachineApps that even if you are, say, an OEM machine provider that makes your own front end, you're going to like MachineApps tools to maybe supplement what you guys are bringing to the market. So let's take a look at that and keep an open mind to what MachineApps can do for you and your company. First, a new MachineApps camera module. This is our first swing at the plate, as they say in the US here in a baseball analogy, which allows users to show a USB camera in a machine app. This is something that we're looking for customer feedback on. What type of cameras are you using? What types of things do you do with vision systems? And we're going to keep building upon this and hearing your feedback, all right? But what's available in this first release of this new feature is the ability to grab a USB camera off your computer and then show it in a machine app. And here you see we're looking at a basic circuit board, and in camera view, it shows up nicely integrated next to a data visualizer, the message log viewer, which we'll go over in a second, the jog pad, the axis dashboard down below, and a set of customizable push buttons in the operator control station over to the right. All of this entire UI was done with MachineApps from Aerotech. In the camera view, the user gets options such as capturing images. There's a little camera to the right that lets you take a snapshot. You can display an overlay, and that overlay is a crosshairs, the yellow crosshairs you see here. You can customize the colors of those crosshairs, the types of crosshairs you're using, what actually shows up in the middle where the crosshairs cross. I chose to have an opening. You can make that a circle or a box as well. So there's lots of little options you can do. And again, you can make that any color you want. The yellow happened to show up nicely on my screen, so I picked that. Then down below on this axis positions drawer, I showed expanded in the call out here in the visual call out. You actually see the positions of the axes as well. And what's nice is that when you hit that snapshot, if these axes are set up, those positions get saved with the metadata of that snapshot. and you can use that later for different things programmatically. Okay, in the gallery view, you can select a captured image to show or delete the image directly from this interface, okay? And you'll see on the right-hand side, I have this big call out of different types of images I've taken with the Machine App camera module. And then you can view the axis positions in the axis drawer. Where was I when I took this image? So it remembers those things and it shows it to you when you pull this back up in gallery view. Jumping back real quick, camera settings. Wanted to call this out. This is where you would pick what camera you're using and what resolution you want to display. Okay, and that you'll see is in the top right of the module where you click on that and that would pop up in your module. So that's a very exciting new tool for us. Try it out, let us know. Any feedback you have, please send it over to Aerotech. Next up, the message log viewer. This message log viewer allows you to view these messages that are written to the message log. In a machine app, you'll see here, you'll see the message log is available in the programming module. You could turn that off. You don't need to show that. And then you can actually just focus on the message logs in a dedicated message log viewer module inside of Machine Apps. You'll see the date and timestamp is there. Severity level indication is there. There's 4 different choices you can pick from. I'm using error. And then the custom messages as defined by the user are there on the right-hand side. And we already went over these messages in a previous slide. So this is a great tool for the actual machine app itself. And I'll just take a note here that this is inside of what we call a module container. And that means 3 different types of modules are contained in this machine app in that top right quadrant area. And if you wanted to click on the variables in IO or the task status module and have that be what your operators normally see, that's possible, okay? So even though you have the viewer that's accessible in the machine app, it doesn't need to be the focus all the time, which is a nice feature of the Machine Apps tool just in general. One more call out here to the actual message log in the programming module. Again, as I noted, when you go in to edit the module, and pretty much every module in Machine Apps is editable and customizable. So not only can you customize the overall interface, each module itself has customizable settings. You can click to not show the message log in this view and just focus on the message log viewer module and not have this feature of the programming module show the message log. And a note, the message log viewer is always active in the develop workspace. So in our actual program development space, we show this message log to you all the time. If you use the message log functions, they'll show up for you. That's what makes it such a great tool for development, debugging, troubleshooting, and those types of functions. Moving on to access control for machine apps. Access control for machine apps has different settings that you can give a user or a group. And the first one is all. It allows you access to all machine apps, including machine apps created after access control is configured. And the next one is you can either customize it or just say none. And this means any newly created machine apps after you give a user or group that setting will not be opted in. You'd have to go back and manually add in new machine apps to that user or group, okay? And that's done for the purpose of just safety and protection, with the assumption that if you're starting to be real specific about what people can access, you don't want to just start throwing more machine apps in there just because. Why do people want to use this with machine apps? So this creates a login screen to get to your actual controller. It enables access control in the controller. And depending upon what user or group permissions you have or are in, you'll only see certain machine apps. So if you're deploying machine HMIs and you say, okay, I only want my operators to be able to use the most simple machine app that they can load and run a part program, and I want to kind of protect them from everything else and not even let them log into Automation1 Studio or any other Automation1 software tool, you can now do that. If you want to have a super user, I'll say, for your HMI that can do everything and has a much fuller featured machine app for troubleshooting or other machine use cases, then yeah, you can set up that technician or engineering level machine app as well. And they can also see the operator interface. So it's really to deploy different types of users in machine apps by controlling which machine apps people can see and use, okay? It allows you to create sort of persona developed machine apps that are targeted towards certain types of users in your end user's work environment, okay? So that's the purpose. There's been a whole bunch of other improvements done to machine apps. We continue to invest in this tool. One thing we got from users is that they wanted to have the override jog speed ability and jog distance in machine apps. Users can now override their jog speed and distance. They can click this override jog settings you see in the bottom right, and they can type in the exact speed or distance they want to jog when they click that button. And this is great if you know how far away you are from something that you want to move to. Say I know I want to move a specific number of millimeters, degrees, microns, whatever you're programming in. Type that in, hit the jog button, you'll go right there. We've added a MachineApps shortcut. Some of our users have said, hey, this MachineApps tool is great, but I want to just use one machine app and I want to launch it from the desktop, or I want to be able to launch it from my own application. So we gave you the ability to have a command line arguments and a Windows desktop shortcut. I have a screenshot of the one I created on my PC just for the purpose of testing out this feature for this presentation. So this is all available in the help file. You can see exactly how to do this. And then there's also another improvement we have that kind of helps you out across all of Automation1's tools, but also in MachineApps, because you're often using industrial Ethernet because you're building a machine with an HMI. And now the customizable buttons and indicators modules can use these industrial Ethernet mappings as conditional operands for pages, button states, and indicator states. So we're doing a lot of things in MachineApps that are state-based control of your HMI, including what pages of buttons you're showing users, what are the actual states of the buttons that are there. Are they inhibited? Can you not use the buttons when they're in certain states? Well, you can use your industrial Ethernet mappings to drive these conditional logics that drive what state your MachineApps features are actually in. It's a very powerful way to use MachineApps. Okay, and again, we're not done yet. There's even more improvements, okay? Let's just start with access control improvements. We focus on user safety, user and group management improvements, and a configuration summary improvement by a less is more kind of approach here. So on user safety, you can no longer edit permissions for the current user. That ensures at least one user will always have admin permissions. So you're never going to lock yourself out with access control anymore. So I think that's a very good thing. User and group management, to add users and groups, you can use dedicated buttons to get to different users or groups. So you're no longer confused about what you're actually doing. And to delete users and groups, there's dedicated icons for like the little trash can to just get them off the access control if you desire to do so, okay? It used to be that we showed you the configuration summary right there in the configure workspace without diving into the access control wizard. That was kind of not so nice, right? You really were confused about, is this the edit screen or am I not in the edit screen? So we just took that away to make everything a lot more clear for our users. Module improvements. There's tons of improvements done to all of our software modules that build up the Automation1 Studio application. We improved the homing module with a wizard-like interface for gantry axes. We improved the programming module, specifically performance levels for large AeroScript programs, and then improved the build and load operations user experience as well. Cleaned up some things there. Inside of the classical tuning module, we improved your open loop tuning and closed loop tuning servo gains and active servo filter calculations. So you're gonna get a lot better calculations actually when you're using those tools. In the data visualizer module, the time scales can be set to milliseconds or minutes now. So a little bit more flexibility there on your time axis. And you can now plot industrial Ethernet mappings as signals. So not only can you use these as conditions in a machine app, but you also can plot those as signals in the data visualizer. And the user experience, we just improved some of the dividers between different modules in the workspaces, and it makes it a lot easier to use the application and to kind of navigate your way around things and quickly change your view and the way you interact with the application. That feature maybe seems, not like a big deal, but when you start using the application, you'll see what we did there is very nice. On the command queue features, command queue is a feature that requires you use both API programmatic functionality, but also use some AeroScript to interact with that. And just in general, we improve some user safety around command queues, knowing the reasons people are using command queues, wanted to make it a little bit safer for people using those things so mistakes are not made. So you can no longer interrupt motion while command queue is being used on a task. And you can no longer issue the program reset AeroScript function while command queue is being used on a task. These are things you just wouldn't want to do. We also added the command queue line number to some of the enumerations. The first one is the task data signal, and the second one would be the task status item. And this just reports the line executing when you use a command queue. And finally, here on the right-hand side, in the .NET and C API, we significantly improved the speed when you add AeroScript commands to a command queue to an average of 1 millisecond. So this is a great improvement. But if you ask me, hey, what if I want to do more than one command every millisecond? We have you covered. You can add many, many commands within the 1 millisecond window by passing a multi-line AeroScript string to the execute API function. And you are to include all the commands to execute within that millisecond. So this is possible. We made it more powerful, not less powerful, believe me. AeroScript improvements. Some real nice things. We've kind of really had to dive into customer use cases to really understand and fix for our users, but that's what we do, right? We understand our users and we try to fix the problems that they're having. And we did that with some of these G-code improvements. If you use G-code, you know lots of G-code supports this dot notation. Well, we support it now for our custom M codes and G codes. None of our standard G codes and M codes have dot notation, but people want to customize and they like to use the dot notation for those customizations. Some of the NIST standards and G codes use dot notation. So now we can allow you to make those customizations on your own. And then you could also specify an N code on the same AeroScript line as a custom G code or custom M code. That was a sort of oddball restriction, probably something we missed, that you couldn't do that before, but it's fixed up now and makes the G code feature a lot more usable. And then the ability to specify hexadecimal numbers immediately after GM or N letters, that was removed. It was a little bit confusing for our programming language approach, and not many people were using that. Please get back to Aerotech if that creates an issue for you. The application indicator function usability was improved just by improving descriptions in the help topics about how the app indicator on function works. We do better checks for reals right now, added to AeroScript. You can check if an AeroScript reel actually goes to infinity or if it's not a number. You can do better checks for strings. We added a string is valid check. And this is necessary to make sure that an AeroScript string is valid before you read the string from a file or from a socket. So a little bit of a feature out of necessity here, but allows you to have success using the new socket feature. More improvements. On the .NET, C, LabVIEW, and Python APIs, we improved the encode documentation of the abort and disable commands in the API. Some notes here are listed for you if you want to dive into that. We also improved the encode documentation for how controller files are written in the APIs. And it more clearly states what goes on when you're writing controller files with the API. Very nice feature improvements were done in the Python Callbacks API. This was also done in C. We're going to talk about that in the next slide. But the AeroScript callback function is what you would use in AeroScript to interface with Python, with a custom Python application. When an Automation1 controller task executes this callback function, the program execution actually waits for any registered Python callback handler to execute. So you'll see on the right-hand side, there's a callback function in the bottom box that goes up to the Python application in the non-real-time layer where there's some callback handler in Python waiting to get indication that it's turn to go. So it tells the callback handler that it's completed, and then the AeroScript function down at the ISMC at the real-time level is able to proceed on with what it's doing. So it's a nice kind of way to handshake between two different layers of your application, and that's now available in Python. And the C API, we actually just released a C API help documentation as a fully featured help like the .NET and Python is already. So for anybody using C, it's a lot more user-friendly now that you have the help files. You can specify any millisecond value for the period of data collection in C now. That's another nice new feature. We added the Callbacks API, which is the same as what we described for Python, but for the C language. And we also have a configuration API in C where users can now change configured parameters and configure calibration through the C API. And please note that those changes will not have an effect until you actually reset your controller. Okay, but it's all accessible from C API now. On the Galvo laser scan heads, we have more improvements. We have a new feature that you can now unload two-dimensional Galvo calibration and Galvo power correction files using the calibration unload AeroScript function. This goes along the lines of being able to change calibration without resetting your controller and having to rehome your Galvo axes. So that's another powerful feature for these users, especially because oftentimes Galvo users are working at different field of views that have different power calibration and correction factors that they want to calibrate for different depths of field of view. And they might not want to reset their controller and take that time hit to their process. We removed the home speed limitation for the Automation1 GL4. We once limited to 8 degrees per second for home speed. That's because we had lots of scan heads that going too fast during homing could have caused an issue. We fixed that issue mechanically already, and most of our scan heads, if not all of them now, are shipping with traditional limit switches that really prevent that from being an issue anymore. So now we let you home faster. You can home as fast as correct for your application and not have this slow 8 degrees per second limitation. Moving on to gantries. Again, AeroTech is a company that does so many things. Galvo scan heads, and now we're talking about gantries. So in 2.5, we also introduced gantry checklists. And this is a checklist sidebar, which is what you use coming out of our machine setup tool. Now has steps for both spars of a gantry device. So if you choose a gantry device, the checklist tool updates what it does in response to the choices you make as a user. There's been tons of device catalog improvements for gantries. It's very much streamlined and much more clear than it was before for gantries. And we really focused on what we call rigid linear gantries in 2.5. That's a gantry type AeroTech ships the most often. And we stand to continue to improve gantry and device catalog for different types of gantries that you can imagine, right? Like say maybe a flexible linear gantry, or for those of you who use gimbals from AeroTech, those are configured as rotary gantries. All of those things will one day become part of the device catalog, but for now, our most pervasive gantries, these rigid linears, are in there and very, very nice and simple to set up. This also included a lot of help file improvements as well. That's really not listed here, but all the improvements we made in the configuration tools were documented in our help and making those things more easy and accessible to users. What AeroTech calls current command gantry, where the current command output of one drive is communicated to another drive and it mirrors the current command. This type of gantry that we call a gantry mode can be created without a feedback device on the second spar now in the device catalog. So if you think about that, if I have 3 or 4 motors in parallel on one axis of motion, I can run all those axes by one feedback device. So there's no reason to limit a user to saying you need a feedback device for every single motor that's in a direction of motion. So that's a lot more flexible for people that are trying to get motors in parallel to drive one axis of motion. People do that because they want more current output. So it's a way of taking multiple drives, kind of pairing the current output of them together in order to get more current to one axis. We also focus on user safety in device catalog. The device catalog validates consistent gantry specifications now. There was homing module improvements. The homing configuration wizard now includes a gantry alignment tool. Users can now configure homing parameters for both gantry axes and perform gantry alignment. We're not done yet. Frequency response modules improvements. How much could we do in 2.5? It's only 4 months. It's only one release cycle, but we did so much in this release. It's really quite impressive. We added progress indication for when you're measuring frequency response, so you're not sitting there wondering what's going on. Something is happening. We also added more controls, and these little blue arrows up and down allow you to actually do the phase, the loop shaping that you're seeing in the graphs above. So the gray lines are where your frequency response measurement was read at. And then when you move these blue arrows, you create this blue line shift that says, this is where I'm moving my gains, and this is how we predict the frequency response is going to end up. So instead of having to type in actual raw numbers, such as the ones by the K value or the KIV or the KIP values, which will also change the loop shaping graphs, you could just do something as quick and easy as pushing a button. It's a user experience improvement for sure. It's what we had in previous software products from AeroTech, and it's something I think our users are really going to like. Again, we continue to make improvements, bring more information to the user. You can now calculate and show the magnitude and phase crossover information without having to try to guess at where they are by trying to put the cursor on the plot and say, well, I think it's about here. No, we calculate it for you. We give you accurate information. All you have to do is click view details and you can see exactly what these numbers are. More improvements. The graphical interface now conditionally wraps the phase curve when it's more than 0 degrees. It won't be wrapped if it's only more than 0 degrees for a short time. So there's some buffer on that, but it is done in general to make an improvement the way we show you information. We now include feedforward filters for the different types of responses, including feedforward, inverse feedforward, closed loop, and closed loop error response types. So these are very useful for controls engineers who are trying to filter the feed forward in these types of responses. We've improved our encoder output configuration improvements. What does this mean, right? That's a whole mouthful, right? So users can now specify the drive pulse stream configure AeroScript function to use either quadrature and clock and direction when the pulse stream signal is configured to point at an encoder output. So basically we have this concept of a pulse stream in AeroScript that you can send pulses to the drive, where those pulses can be either quadrature pulses or clock and direction pulses. They basically emulate an axis of motion, and we basically are sending these pulses to have like an emulated axis of motion sent to the drive. You can send that emulated axis of motion as a clock and direction output to an encoder on a drive, and you can use that for anything your creative controls mind can tell you to do. All right. You can also send out a quadrature. So if we're trying to send quadrature output, you can create a virtual axis in AeroScript. You can say, I'm going to use that virtual axis and track its movement to send quadrature signals to a real drive and output those quadrature signals as if you're outputting the motion of an actual axis of motion. And then you can use other things in your control architecture, third-party devices, to follow that quadrature output or to follow that clock and direction output. So it's very powerful, and it's really a tool that's meant for controls creativity. The PSO improvement. This affects all drive hardware. Users can now output a pulse on a PSO output that is synchronized with your data collection. So if you set up what we call a drive data collection, the PSO output can be synchronized to the frequency you're collecting data at or the PSO locations you're collecting data at. And we just made a default 50% duty cycle for this, and it's at the same frequency again as your data collection. We also added bits to the PSO status item to report the status of new Automation1 features. You're gonna have to dig into the help files to learn a little bit more about that one. We improved encoder echoing. Again, this affects all drive hardware. This helps evaluate encoder signals passed between drives, which is something that's often done for position synchronized output and infinite field of view features. So again, this is a nod to usability. We added an MX quadrature warning bit and an MX quadrature error bit to some of our status items as well. We made feedforward improvements in 2.5. The laser scan head drives, the GL4 and XL4S, have improved the accuracy of drive feedforward calculations. And this might show you some small changes in performance. Pay attention to this as you upgrade to 2.5. If you're currently using laser scan heads, see how this changes your program. If this creates any issues for you, please don't hesitate to create a GTS issue. We also added support for snap feedforward. This snap feedforward parameter is another thing that helps Galvo scan heads get higher performance levels by predicting the amount of snap, which is a derivative of jerk, in your motion system. So that's another nice feature we have in the scan heads for performance. And the drive now interpolates feedforward current at the drive level. So at the controller level, you can set this parameter at any value. You're not limited anymore by having to be at some divider of the servo speed. You can now set this up to be whatever you want it to be, and the drive will handle that for you. And finally, an installation note. The Automation1 MDK now requires a .NET 6 desktop runtime. If necessary, it's installed automatically when you install the MDK. So you might see this pop up if you're installing 2.5 on your computer. So that's it. There's a whole lot of information here. I really appreciate your time for taking this training. I hope you're excited about all the development and new work we're doing in Automation1. And as always, expect more new and good things to come as 2.6 is already in development.